All right. Let that be it done. Let me get these gentlemen. Okay, let me share my screen. Start the broadcast. And we'll start here. All right, gentlemen. Let me see. So welcome, scholars. We are at the end of week 7, so that means next week is going to be devoted to our exam 2. It's not really a midterm, it's just exam 2, and your midterm grade is going to be based on everything due before exam 2, including exam 2. So today is a homework session where we're going to go through as many homework questions from section 1.6 as we can. Okay. As usual, if you have questions, feel free to unmute yourself to get my attention, or type it in the chat. Wow. I do have this already open. I was like, I knew I did that. I was like, I had this already open, ready to go. Okay. I guess we'll do our usual and just kind of jump around at random. Hey, Google, give me a random number between 1 and 19.
10.
All right, let's check 10. Let me close this. I don't confuse myself later. All right. So this says the functions f and g are given. Evaluate f compose g and find the domain of the composite function of f compose g. Let's take some notes on this one. Let's take some notes. And I'll check the attendance again at about the 15-minute mark for anybody that's coming late. So if you have brothers in the waiting room and they're like, hey, can you have them let us in? Tell them they need to wait until about the 15-minute mark. And I'll check it again. I usually try to at least let 15 minutes hit. I might be a little bit after that. As long as they wait, they'll get in there. Okay, let's hop here. And let's paste. Allow the paste. Cool. Come on. Come on, you can do it. Okay. So it says the functions f and g are given. So f compose g, right? Okay. Hello. Just a moment. Oh, wow. Okay, so they got lucky. Like the best practice is to get into the waiting room before 2 o'clock. Like after 2 o'clock, then you run the risk of running into that second wave, and it kind of gets worse from there. Okay, this student. Student. And where's the last one? There he is. Let me refresh this. So it says 20. Yeah, that looks right. Cool beans. I really appreciate Blackboard for the ease of taking attendance. It's very user-friendly, much more user-friendly than Starfish when it comes to taking attendance. Okay, so let's continue where we left off. So these two functions are given, and we're asked to find f compose g, right? Okay, so as usual, what does that symbol mean, right? So then f compose g, this means f of g of x, right? But what's our g of x? Our g of x is 2 over x. So what we're doing, okay, again, f compose g means the second function inside the first function. And then with this last part, we're basically writing f like normal, but we are replacing each x with the green thing, okay? So first I'm going to replace the x with a blank set of parentheses, plus 1 under 5. And what goes into the blank parentheses? The green thing, which is 2 over x. Let me shift this stuff around a bit. There's no need for it to. All right. God bless me. All right. So we're here. Okay, so this is a complex fraction because we have one fraction inside of another. So to simplify a complex fraction, we multiply by 1 in the form of the LCD over the LCD. So the LCD of our fractions is our x. So we're going to say times 1 in the form of x over x. And what this does, it just clears out those additional fractions. So if we do this on, let's do the bottom. On bottom, if we distribute this x, okay, we're going to get 2 plus x on bottom. And on top, we're going to get 5x. And that's a lot more user-friendly, okay? So that's F composed G. And then remember, there's a 3-step process I do for finding the domain of a composite. So the domain of F composed G. One, I like to find the domain of our inside function, which is G in this case. So domain of G of X, okay? So G of X by itself is a rational function. In general, rational functions, the domain is all reals except any x that makes the denominator 0. In other words, when x is 0, that makes the denominator 0. So we want everything except 0. So I'm just going to abbreviate it just by saying x is not equal to 0. Okay. So the first thing is we found the domain of an inside function. Then we found the domain of our simplified function. So the domain, I'm just going to abbreviate it as the simplified, right? Okay, so that's going to be this guy right here, right? So again, for a rational function, in general, the domain is all reals, x is -2, it makes the denominator 0, right? So we want everything except -2. So x is not equal to -2. So then the third step is we take the intersection of those two sets. So take their intersection. Okay. So let's do this on a number line. Okay. So say this is our positive x in this direction, and we're considering -2 and 0. Okay. I think both of these make the original function undefined. So we're going to capture that like with the vertical bar. Let me see. What are we doing? Oh, let's not do that. Let's do it like this. So, okay. So the domain from G, let me see. I need some colors. So what colors are that? Blue and yellow. Purple is what? Red and blue? Okay, we'll do purple. Okay. So for G, well, that's what? Everything except 0? Purple is what? Red and blue. We'll do this one in red. Usually don't like to use red, but that's okay. And we'll do this one in blue. Here. Okay. So for G is everything except 0. So that means we would capture everything to the left of 0, everything to the right of 0, and 0 would get a parentheses showing that we do not want to include 0. So we get infinitesimally close to 0 coming from the right, infinitesimally close to 0 coming from the left, but we do not include the number 0 itself. And then for the simplified function is everything except -2, right? So we want everything to the left of -2, everything to the right of -2, but we do not want to include -2 itself, okay? So then we ask ourselves, well, what do these two sets have in common, right? If we were to lay what do they both share? Well, they both have everything left of -2. They both have all the numbers between -2 and 0. and they both have all the numbers to the right of 0. Okay. So then we want to exclude -2, and we want to exclude 0. Right? So then the intersection of the red with the blue is going to be the purple, and the purple in interval notation. The far left is going to be what? -infinity up to -2. And then we can include all the numbers from -2 to 0, and then all the numbers from 0 to infinity. Infinity always gets a parentheses in this context. Because we do not want to include the -2 and 0, they also get parentheses. And we combine these sets with union. So this is not a U, this is a specific symbol. This is a symbol called union, right? And it comes from logical set theory. Okay, so that's our domain, right? That's the long and short of the domain. So we got 5x over 2 plus x. 5x over 2 plus x. And then basically we wanted everything except -2 and 0. So we do, as soon as I can find it. How come I can't see it? Maybe I should just use my keyboard. I can type all this faster than I can find it. Let's just get rid of this. Okay, so the far left is what? -infinity up to -2, parentheses, and then we're going to say we want union, so that's like -infinity to -2, and then we want from -2 to 0, union 0 to infinity. Okay. Interval notation, cross our fingers. God is good. Okay. I guess I do usually like to wait until the 15-minute mark. Let me wait for at least another minute or so. Hey Google, give me a random number between 1 and 19.
13.
Lucky number 13. All right, let's look at it. Oh, and it's 213. I wonder if that has anything to do with it. So let f be this and g be this. Find each composite function and describe the domain result of the resulting function. So g inside of f, the square root is going to cancel. So it's just going to be 4x. Let's think about this. Oh, I forgot to square the 4. So 4 is squared. I didn't see that other 4. 4 squared is going to be 16 times 4 is 40 plus 24, 64. So I think it's going to be 64x. Like this. 64. Okay. So then the domain. The domain of the inside function is what? 0 to infinity. The domain of the simplified is all reals. So 0 to infinity intersection all reals is just 0 to infinity. So that one's going to be open parentheses 0 to infinity. And if anything is not clear, feel free to unmute yourself. Let me think. Square bracket, right? Because it can be equal to 0 because square root is defined for 0, so there needs to be a square bracket. Okay. Again, if anything is not clear, feel free to unmute yourself to get my attention and we can talk about it. Let me check on you guys in Zoom. See if we got any latecomers. Let's get the student. I have it here. Got him, coach. Got him. I'm totally sleepy. I'm always sleepy when it comes to you guys, and it gets harder. I got at least 2 more classes immediately after you guys. Did I eat lunch today? I mean, I ate breakfast. I didn't eat lunch. So I mean, maybe that's why I'm not so sleepy. I was working on a painting project. I just finished like earlier today. I worked on it. It took me almost a week. So that's gonna be a pretty penny. Painting is like so therapeutic, and it's like so different from math. Math is like logic to the point, no questions. It either is true or false. And painting, you're just like, I'm just doing this because I feel it. I'm angry. Pop, 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 pop. Or ooh, light. Okay, let's be neat. Or you can just whatever you feel, you get it out. G compose F, right? So F is inside of G. I should write it out. We're going to take the square root. Again, the squared and square root are going to cancel. Square root of 4 is 2. 2 times 4 is going to be 8. So that's going to be 8x. Let's try 8x. Okay, let's get rid of this. Go 8x. Okay, if I need to write it out, just let me know. Oh, absolute value. Okay, that makes sense. So, the squared forces that number to be positive, so we capture that by making it absolute value. Okay, so whenever we have squared inside the square root, that result is absolute value. Because when you do the squared first, that forces your number to be positive, which is basically making it absolute value. And then when you take the square root, that behaves the same way as absolute value, okay? The domain. So the inside function is F. That domain is all reals. The domain of the simplified is all reals. All reals intersection all reals is all reals. Negative infinity. So what I'm doing in that little brief, I'm basically just quickly doing what I wrote out a moment ago, right? In the previous example, I wrote out my 3-step process. Now, instead of writing it out, I'm just doing it quickly in my head. First, I'm finding the domain of the inside function. Then I'm finding the domain of the simplified function. Then I'm taking those 2 results and taking their intersection. F compose F. So 4x squared. So that's going to be what? 16x to the 4 times 4 is 64x to the 4. Is that right? Mm-hmm. I think it's 64x to the 4, 64x. And I should probably be writing this out. I'm totally being lazy. Okay. The domain of F compose F, okay. The domain of the inside is all reals. The domain of the simplified is all reals. All reals intersection all reals is all reals. Okay. G compose G. The square root of 4. Okay. So the square root of 4 is 2. Then we're going to have the square root of the square root, right? So that's the same as x to the 1/2 to the 1/2, which becomes x to the 1/4. So it becomes the 4th root. So then 8 times the 4th root of x. Let's see. 8. Let me see. I think it's in root. So we said the 4th root of x. I think that's it. Let's go with this. Okay, so G, the domain of the inside function being G is going to be what? 0 to infinity, that inclusive with the square bracket. Okay, so because we're doing an even root in general, without transformations, the domain of an even root is 0 to infinity. So I think they're both 0 to infinity. So then this ultimately is just going to be 0 to infinity. A set intersection itself is itself. Okay, I went through that a little quick. I feel like there should be questions, but I can't make you talk. I mean, no, I can't. I can coerce you and like prod you, but I can't make you. You always have a choice, right? Okay. Hey, Google, give me a random number between 1 and 19. Oh.
11.
Did anybody go to the Kamala Harris presentation yesterday? I started to go. I had class. I could have canceled class. I was really tempted to, but I was like, no. Because I really wanted to ask her some questions. If I was there, I was going to act a fool. I would have been like, Vice President Harris, how do you justify, sending billions of dollars to Ukraine, but we have homeless here and our teachers are underpaid and we have the Hawaii track. You know, I would have been like asking her those hard-hitting questions. Like I would not have cared because I'm serious. I'm like, how do they justify it? You know? I really wish I had gone so I could have asked her because, you know. And then there's a strong possibility that she's going to become president. Like The Simpsons predicted it. You know how, I don't know if you guys are aware of the whole, Simpsons predicting things like to the T with images. Like they show Trump coming down the escalator before it happened, like to the T. And so they have clips where Lisa is president, but she's wearing that classic like purple blazer that Kamala Harris wears sitting at the Oval Office. And so then it's like, oh man, how did she become president? You know, like did something happen to President Biden? You know, and it's a couple of ways that it can go. Obviously, you don't want anything to happen to anybody, but that's the buzz. Just when it comes to The Simpsons and that kind of stuff. But they got some eerie predictions, and they have done a bunch of them. Like it's really creepy how accurate they have been throughout the years, like with random stuff. Like they'll put it in their show years before it happens, and then when it does happen, is like it's exactly how it shows up in their show in the cartoon a lot of times. Let me go here. I don't know if anybody went to that. This was fine. Okay. Okay. So the functions f and g are given. Evaluate f compose g and find the domain. Man, are all of these like this? Second function inside the first function. So it's 2 minus 5x minus 4. So 2 minus 4 is negative 2. I think that's it. Factoring out that negative doesn't really help us. So we're going to go square root. We said negative 2 minus 5x. Okay. So our inside function is g. The domain of g is all reals. The domain of the simplified. So that radicand, the part inside the radical, has to be greater than or equal to 0. If we solve, let me see, I'll take some notes here. I should write it out. Let me see, but I'm not going to. Negative 5, at least not right now. How do I do greater than or equal to? Yeah, okay. So that part needs to be greater than or equal to 0. If we solve this, add 5x on both sides and divide, we're going to get a negative 2 by 5. Oh, negative 2 over 5 here, and x on the right-hand side. All right, so what I had before, if I solved it, I would get this. So this domain is x is less than or equal to a negative 2 by 5. Let me think about this. That becomes a positive 2, which gives us 0. Okay. And the original was what? All reals. So all reals intersection this is going to be this, but we need to write this in interval notation, right? So if we were to plot negative 2/5 on the number line, do we keep everything to the left of negative 2 or everything to the right? If x is smaller than negative 2/5, we keep everything to the left, right? So then that means we're going to go from negative infinity up to a negative 2 by 5. That's not a negative. Negative 2 by 5. And we use a square bracket there. Let me get rid of this other stuff. Let's go with this. Okay. Let's hang up for at least 15 more minutes. Hey, Google, give me a random number between 1 and 19.
Here's a random number, 7.
7 heaven. Rhymes with 11. Okay, f of x, g of x, f compose g of negative 1. Okay, ouch. So I'm just going to do this in my calculator just because we can. I can get this to behave. We left it off here. We want the calculator. Okay. That looks good. Let's clear. So let me think. You know what? We might not even need to do all that. So if we do g of -1, that's going to be 3 minus 5 is -2, right? And then we put, so that means we're going to do f of -2. That's going to be a -10 plus 2 is -8. Let's just go with -8. So again, what I did, again, f composed g just means the second function inside the first function. So this is really f of g of -1. So first I found g of -1, I got a result of -2. Then I took that result and plugged it into f, and I got a result of -8. Hey, Google, give me a random number between 1 and 19.
18.
Let's see. Express this function as a composition of two functions. So this is pretty much guess and check. Okay, so if our f of x, let me see. We want the inside function. So our g of x needs to be like x cubed minus 3. Okay, it could be d. Let's check d. D looks good. So when we say the second function inside the first function, right? Because a was kind of the diversion, right? Let's check. Okay. Hey, Google, give me a random number between 1 and 19.
Here's a random number, 3.
Given this f and g, find all these and then determine the domain of each, right? So f plus g, basically we combine like terms. There are no like terms, so we just write each one out. So it's going to be 2x to the power of 2x squared plus 5x plus 1. Oops, plus 1. Okay. So then the domain, I think it's just all rows. F minus g. So f minus g. Okay. So still no like term. So I'm gonna leave it as 5x plus 1 minus 2x squared. And all reals again. Check. F times g. Okay, so we're going to distribute g into f. That's going to give us 10x to the power of 3, 10x to the power of 3 plus 2x squared. And all rows. Like, there are no restrictions. We're not dealing with any square roots. We're not dealing with any fractions. No, nothing like that. F divided by g, nothing cancels. So we're just going to say 5x plus 1 divided by 2x squared. I think this is fine. And okay, so with this division, the main thing is we cannot divide by 0. So we have to throw out any x and make the denominator 0. In other words, we got to throw out x equals 0, and that's captured by d. Hey, Google, give me a random number between 1 and 19.
Here's a random number, 17.
17. Let's see what's going on in 17. So find f and g such that f compose g. Suppose that g of x, so our inside function is x minus 2, then f of x needs to be 1 over x. Hey, Google, give me another random number.
10.
Okay, so we'll do 12 since we've already done 10. Given this f and g, find each composite function and describe the domain of the resulting function. So f compose g. So we're going to have 4 times those items. I'm going to take notes here. So my f is going to be what? 9 minus 4x. But my x is going to be replaced by 5 plus x squared. Okay. So then if I keep going, if I distribute that -4, I'm going to have what? 9 minus 20 minus 4x squared. Okay. But then if I combine like terms, what is that? A -11. So -4x squared minus 11. Let me get rid of this other stuff. Wrong button. Be nice if I could just jump straight to home, but that's not working. So gotta click. Okay, so we got -4x squared minus 11. Let's cross our fingers. Okay. So then when we want this domain, the domain of the inside function is all reals. The domain of the simplified is all reals. So all reals intersection all reals is all reals. Negative infinity to infinity and beyond. Right? Okay. G compose F. Okay, let's take our notes here like we did before. So first we're going to write g of x like normal, but we're going to replace each x with a blank set of parentheses. So we got this 5 plus x squared, squared, right? And then we're replacing each x with f of x, which is going to be this 9 minus 4x, okay? So then if we expand and simplify, we're going to get 5 plus, let me think, yep. 9 times 9 is what, 81. 2 times 4 times 9 is 8 times 9 is -72 minus 72x, and then plus 16x squared. Okay. Then if we combine like terms, it's only the 5 and the 81 to make it 86. Yeah, I think we're okay. Let's get rid of the 5. Let's get rid of all this other stuff. Okay, cross our fingers. God is good. All right. Okay, let's keep going. All the time. So now, we did G compose F. The domain of F, which is our inside function, is all reals. The domain of the simplified, which is a quadratic, is all reals. So then all reals intersection all reals is all reals. Negative infinity. See, now I have this urge to watch Buzz Lightyear on Disney Plus. I just be like doing free marketing for these people. Like they owe me money for real. Because I do feel like watching kind of like Buzz Lightyear, but then also within a week,
Wait,
the
the
latest
one with 2000s?
Huh?
Wait, you mean like the movie or the series that was released in the 2000s?
I didn't even know there was a series. No, just the movie. But then that's
okay.
also supposed to release The Haunted Mansion with like Tiffany Haddish, and I tried to watch it in theaters, but I kept falling asleep in it. But I think it was actually a good movie. I just couldn't, I don't know. I was just like, no, I want to go to sleep. I tried watching it twice and I just, so I've been waiting for that to come out, and then, I can see all the stuff I missed, Okay, with C, F compose F, right? Okay, let's do our notes here. That seems like it's been working for us. So then we got 9 minus 4x. Okay, but the x needs to be replaced with a blank set of parentheses. And then into the blank parentheses, we do another f of x, so another 9 minus 4x. Okay, so then if we distribute that -4, we're going to have 9 minus, what is that, 36 plus 16x. Okay, if we combine like terms, what is that, 27? -27? So 16x minus 27? I feel like the TV series, I mean, it's all animated, so what about a live action Buzz Lightyear? How would that work? Would that be any good? I wonder if Tim Allen would make an appearance. See, now my mind is just like going other places. Okay. All right. So we got that, and then the domain. The domain of the inside function is all reals. The domain of the simplified function is all reals. So then all reals intersection all reals is all reals. Okay. G of G. Okay, let's just take our notes here. So we're going to write G of X So you see how like repetitive this is becoming? That repetition, you see how the speed at which we're going through these is like exponentially faster than when we first started, right? Just it's because of all the repetition. Are you gonna work? I think I need to stop moving the screen. Okay. So G is 5 plus X squared, 5 plus X squared, okay? But then we're replacing X with another 5 plus X squared, okay? So it looks like we need to FOIL. So the 5 persists for right now. That's gonna become what, 25 plus 10X squared, yeah? Plus 10X squared. And then plus X to the 4. And then also, like, I'm in that mood to like just watch all the like Halloween stuff, like Hubie Halloween on Netflix. A couple of years ago, I binged watched reluctantly. I binge watched all of Halloween Horror Simpson episodes. Man, it was torture because like some of the episodes were just like really weird and twisted and dark. What is this, 30, right? So I probably won't ever do that again. So it was just kind of tough to get through it. I was like, but I made it. I got to a point where I was like, well, damn, I've come so far. I don't want to like not finish. You know? I would feel so way if I like watched as many as I had and I just didn't finish it. So I just sucked it up and finished it. Okay, let's hang out for like about 5 more minutes and then I'll let you go. G of G. Okay, so the domain of the inside is all reals. The domain of the simplified is all reals. So then all reals intersection all reals is all reals. Okay. Oh, I forgot my negative. Yeah, that looks good. One thing I kind of wanted to try this year that I have not tried. And Atlanta, like they have one at the Battery, like is trying to escape room. I don't know if you've ever done those. It's like, you know, you and your friends are like locked in a room, but you have to follow the clues to escape. But the thing is, I mean, I'm low-key like claustrophobic, but I know how to calm down now. Like once upon a time in my life, I would have been like, get me out of here. Where's the escape? Looking for the panic button to escape. Because it's like your intrusive thoughts start to take over, you know, and it's like you can feel the walls closing in, but now I know to just like woosah, right? Take a deep breath, chill. You know, it's just a game. You know, you can get out, right? Even if you couldn't, there's always a way, right? You just got to stay calm. It's like swimming. I don't know if you've ever been swimming, but you got to stay calm. The name of the game is to stay calm. Okay. Hey, Google, give me a random number between 1 and 19.
3.
3. Okay, let's do 4. I'm more than likely going to make this our official last one. And their domains, okay. So F plus G, right? So Adam, there are no like terms. So we're just writing everything out. X to the power of 3 plus 3x to the power of 2 minus 5x plus 5, right? No like terms to combine, so we leave it like that. All reals, I think both of their domains are all reals. So we're just going to say all reals. Check. Okay. F minus G. F minus G, okay. So again, no like terms to combine. We just need to make sure that the x cube has a negative. So we're going to say 3x to the power of 2 minus 5x plus 5 minus x to the power of 3. Okay. All rows again, no restrictions. F times G. F times G, so we need to distribute an x to the power of 3. So that's going to become what? 3x to the power of 5. 5 minus 5x to the power of 4. Okay, plus 5x to the power of 3. Another like one of Adam Sandler's recent presentations that I actually enjoyed. He made 2 movies called Murder Mystery. Like there's Murder Mystery 1 and Murder Mystery 2. Those are actually fun. It's him and Jennifer Aniston running around solving murder mysteries. They're fun. Another murder mystery that's good on Netflix is called Glass Onion, Knives Out. if you can get, that's actually part 2 of the Knives Out franchise. There's a part 1, but it's not on Netflix. But the part 1 is a little bit slow, but it was interesting as well. I like that one too. And the murder mysteries are fun. Hercule Poirot. Now, he has a new movie that's in theaters now, but it's a little bit different than his originals. They tried to make it a horror. It was not scary. All they kept doing was like jump scares, and we just went to sleep on it. Like I was like, okay, this is not good. But his other movies were good, like Murder on the Nile, and it was Murder on the Nile and Murder on the Orient Express. Those were good. I like those. They were interesting. I think it's the same restriction, right? All rows. So let's go here. Let's try to wrap this one up and get out of here. Okay, and then the last one, F divided by G. Can we factor that? Ooh, no. There's no need to do that. Yeah. So we're gonna have 3x squared, 3x to the power of 2, minus 5x, 5x plus 5 divided by x to the power of 3. I'm just gonna go with this. Okay. And then again, with rational functions, we cannot divide by 0, so we want all reals except 0, and that's captured in A. Okay. All right, gentlemen, are there any burning questions? We took a few notes. Let me see, what do we have? Is this something? Oh, come on. We just did the 1. I'll go ahead and make this available. Share, set it in the box. Let me put it in the correct folder. 23. Traditional. Notes updated daily. This one. So this should be 61, that's fine. So when this bar finishes loading, you'll receive a copy of anything that you saw me writing that we worked on together. And if there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, enjoy the rest of the day, guys. Take care. See you next week, same time, same place. Peace. Let's see. That's okay. Yeah. I ended up canceling class this morning because my Wi-Fi was not working. And it started working after about like 20 minutes. I was like, wow, I let them go already. So, all right, gentlemen, have a good week.